Hi, my name is Etemutku Aktaş and today I'll be presenting automated issue assignment results and insights from an industrial case. Our case is in banking domain. İsbank, the largest private bank in Turkey with more than 7.5 million digital customers, receives more than 300 software-related problems daily from the field. In our case, we assign the issue reports to the software teams at Softtech, which is a subsidiary of IssueTAG with about 100 millions of lines of code and more than 50 software teams operating in 9 different locations. Our contributions are, first of all, we deployed automated issue report assignment system in a large-scale industrial setting, and we report the results in this context. We saw that it's not just about automating the issue assignments, but also about changing the process around it accordingly. Interestingly enough, we faced two issues that has not been studied before in the literature. One issue was how to explain the assignments to the teams. After deployment, we started having phone calls from the teams, especially for the reports that are wrongly assigned. This was an issue we didn't expect to face before deploying the system. Based on the informal discussions we had with the stakeholders, we quickly realized that explaining the assignments could further improve their trust. The other issue was how to monitor the deteriorations in accuracies automatically. It's important because such a mechanism increases the confidence of the teams and other stakeholders in the system, but also helps determine when the underlying classification model needs to be recalibrated, for example, by retraining the model. The issue management process is business critical for IssueTAG. Problems that the branches and customers face are reported to IT help desk at IssueTAG. They are non-technical staff and about 50 people work there whose main responsibility is to deal with the incoming issues. They resolve them by using basic troubleshooting guides. And if they cannot, they dispatch the issue to the related entity at Softtech. The application support team is employed at Softtech and there are about 30 people embedded in the development teams. Their main responsibility is to manage the collection of issue reports assigned to the teams. If they can resolve the reported issue, they close the report on behalf of the team. Otherwise, they notify the development team about the newly reported issue. However, there were some issues with this manual assignment process. First of all, there is a steep learning curve for carrying out the team assignments for the clerks. And the knowledge base used by the clerks to help with the assignments was maintained in an ad hoc manner, which was error-prone and time-consuming. Incorrect assignments were not only causing frictions between the IssueTAG and Softtech members, but also increasing the turnaround time for resolutions due to issue tossing. So, IssueTAG and Softtech wanted to improve their practices, and we cast the problem of issue assignment to a classification problem. We had to make two decisions before automation: which data mining approach to use and what time locality of the training data should be. We use textual input to decide on the team to assign the issue report. So each issue report has one-line summary capturing the essence of the issue reported and has a description which is supposed to have observed behavior, expected behavior of the software, and steps to reproduce the problem. We represent this textual data as a multidimensional vector using the well-known bag-of-words model. And we use 6 months of data in our experiments with more than 50,000 issue reports assigned to 65 teams. And as a result of our experiments, we have decided to employ a linear support vector classifier. One issue was deciding on the time locality of the training data since the underlying issue database evolves. Machine learning models may need to be trained as needed, and therefore we had to decide on how much we should go back in time to collect the training data. To this end, we carried out a study where we experimented with different time windows. And based on our experiments, we decided to use all the issue reports that have been submitted in the last 12 months as the training data. We deployed the automated assignment system on January 12, 2018. The system is fully operational since then, making automated assignments for all of the issue reports submitted. It reduced the manual effort required for the assignments by about 5 person-months per year, improved the turnaround time for resolutions by about 20%, and slightly reduced the average number of issue totals from 1.50 to 1.49. As I said earlier, we made two interesting observations after deployment. First of all, especially for incorrect assignments, the stakeholders demanded some explanations as to why and how certain issue reports had been assigned to their teams. And secondly, since changes in data occurs over time, how can we detect the deteriorations in assignment accuracies automatically? For explaining the assignments, one requirement we have is that the explanations should easily be interpreted and understood even by non-technical staff. Another requirement is that they should be given in terms of the descriptions present in the issue reports so that the non-technical staff can relate to them. With all these in mind, we conjecture that providing a list of most influential words for an issue assignment with their relative impact scores as an explanation could help stakeholders understand why the issues were assigned to their teams. We used an approach called LIME that generates a set of terms from the original issue report together with their relative weights. An example of an assignment is provided here. The issue report has been assigned to the team Customer Information Management, and the words with the green bars are the words that support the assignment, while the red one opposes the assignment. So in this way, the users can relate the most influential words present in the explanation with the assignment made. To evaluate the explanations, we conducted a survey with the team members at Softtech, and it turned out that the explanations were helpful in understanding the assignments, and based on these explanations, the assignments were found to be trustworthy. Since the data changes over time, the model deteriorates and we need a mechanism to monitor it. We use an approach called PELT, a statistical analysis technique, to identify when the underlying model of a signal changes. We feed PELT with a sequence of daily assignment accuracies as the input signal. The assignment accuracies can automatically be computed using the history of the issue reports that have been closed. When we apply this method to the real data collected from the field, we identified the change points seen on the figure. The dashed lines show the time when PELT detects a change in accuracy, and it turns out that these lines were all meaningful. For example, the third dashed line is the time when the automation is deployed. We observed that after deployment, the daily assignment accuracies dropped slightly. And between first and second dashed lines, there was a major infrastructure change in credit card applications, which took about 2.5 months. So it's a sign that it can take quite a while for a human stakeholder to excel in the issue assignment task. To evaluate the issue assignments, we carried out an additional survey with the application support team at Softtech to find out if the automation is perceived as useful by the end users. The results of the survey strongly suggest that the automation meets its business needs with high quality. Finally, the lessons we learned in this work are: stakeholders do not necessarily resist change. Gradual transition helps stakeholders build confidence, facilitating the acceptance of the system. It's not just about automating the issue assignments, but also about changing the process around it. The accuracy of the deployed system does not have to be higher than that of manual assignments in order for the system to be useful.
Hello, welcome to the live question and answer with Ethem Utku Aktas that just presented his work on automated issue assignment, reporting the result from a very extensive experience with a real industrial case. For the people that are in the audience, as you should know now, you can type your question in the chat. I didn't introduce myself, sorry, I am Antonia Bertolino and I am chairing this session in which we have, in addition to EdChem work, we have two other work. There are, in this case, all three papers published in journal and make a journal first projection here at ICSI. So waiting for the audience to warm up, Ethem, we were anticipating before in the chat. I was curious to know further development about this experience beyond what is in the journal. And then we have one question. So if you say what is that you did after the journal, and then I will read this other question. So further development.
Okay. Further development. In fact, after automation, we observed that the accuracy slightly dropped, and we checked the incorrect assignments. We checked their general properties, and most of them had shorter descriptions. And we saw that sometimes the reporters prefer to write short descriptions and attach screenshots and expect that the developers check the screenshots and see the error there. And they think that they don't have to write too many lines of descriptions. So the first area we are working on is that can we extract more information from these screenshots? In our case, the textual data in these screenshots are more important. We saw that because the image features are similar because they the development teams use similar infrastructures and are similar. So the important feature we saw that in these screenshots are the textual data in them. And another area is that can we give feedback to the reporters to write more about their descriptions? For example, can we check that the steps to reproduce are not present, or observed behavior or expected behavior? And we are working on extracting the patterns, how the observed behavior and expected behavior or steps to reproduce are written in these descriptions. And we hope to give feedback to the reporters that there is some missing information in these descriptions. Okay. And we are working on that.
Okay, so let's see. Aurora asks, thank you for the presentation. Regarding Lime, which instances did you choose for evaluation and why? How you can gather general insight about explainability from this local XAI method?
In fact, we tried to extract instances from different domains. For example, some issue reports from credit card team, some issue reports from I don't know, customer information team, or some reports from another team, and we selected them randomly, and we also saw that the correctly assigned and incorrectly assigned ones was their number were similar to the real situation. So in fact, we selected randomly. How can you gather general insights? For the general insights about explainability. The users are expecting, for example, especially when the issue report is assigned incorrectly, the developers ask why did the system or automation assign this report to my team? So and the problem here is that someone has to find the correct team. Which team will solve this? In fact, the problem here is that in the past, the IT help desk was doing this job, and after automation, the support team does that. So they expect some explanation, and since we use the descriptions, the textual data, we have to select the most important terms that were used to assign that were impactful in assigning these issue reports. So it's an important issue, I think, explainability, because some system does some automated job for you, and it affects somebody else's life. For example, they may be having more issue reports, I don't know, and they ask for explanation. So it's an important issue to think of in such a data mining based system.
Sure. We have another question from Yang Song, and you have almost 3 minutes. Could this method be used easily in other issue tracking systems, since it requires a response from users to evaluate the explanation of the classification result? So could you use it in other tracking systems?
Yes, it can be used. In fact, the users use the check for the explanation afterwards, after it is assigned, and it's first of all, the method is the lime method is not for a specific algorithm. It is independent of the machine learning based algorithm, so it can be used in other domains as well.
Nice. Other question from the audience? We still have more than 1 minute and a half. So okay, I had this curiosity. If there is time, I don't know, we have just 1 minute more or less.
Okay.
If there has been also somehow an impact about using this system on the developers, if they changed somehow their behavior because of the system, maybe to prevent that they are assigned some tough issue, or I don't know. Did you notice if the user changed to adapt to the tool somehow, or to trick the assignment?
In fact, the reporters are in the banking side, in banking domain. They are non-technical staff. For example, they receive the calls from the branches and they create the issue report. And the solver, people, the developers who solve the problem are not do not enter any information about the issue report. I mean, but the staff at the reporters sometimes know the important words for the issue report to be assigned to a specific team.
Okay.
They know that I have to write these terms.
Yeah,
if I write these terms,
It's
Yes.
the time is expired, but okay.